homework and you don't need this part, then feel free to do your own stuff. I am taking up 4.4 homework word problems, and I'm looking at number 14 and 16C. Great. Let's save it. Yeah. Feeling kind of purpley. 14. All right. So, I'll read it. It's a golf ball flying. Okay. So right away, if a golf ball is flying, is the parabola opening up or down? Right? Most of the word problems, are opening down, and that means my A is going to be negative. Okay, so it says a lot of stuff. It's angled at 10 degrees. Who cares? Do you know why who cares? Because they give me the equation. So if they give you the equation, there's a lot of information in the question that might not be necessary. It's just like additional fun stuff. Okay. When I graph, sometimes it's hard to know what would my y and x be. Excuse me. So usually this is my y, this is my x. However, in this question, I look at this equation and I'm like, usually the y is on its own. So that means the h becomes the y-axis. The x is usually on the right side of the equation, right? The x is the one that has the x squared. So that means instead of x, the d becomes the x-axis. Okay? That's sort of how I figure that out. Both of them are in meters. Great. So I'm just going to remind myself, don't forget, Miss Sly, it's meters. Great. Okay. And I'm told it's a golf ball. Now, I'm not told that the golf ball starts on the ground, so I won't assume it. I'm just going to draw a random parabola like that. I'm assuming it doesn't start on the ground. It could be on the ground. It could be something else. I just don't know the y-intercept right now. Although, if I look at this equation, to find the y-intercept, what do I do? So instead of a y-intercept, it would be the h-intercept. At the h-intercept, what is the value of d? Yeah. So if you think about it, if I put d equals 0 into this equation, this becomes 0, right? Because it would be times 0. This becomes 0. So where does the golf ball start? It does start at 0, 0. Okay, so I can redraw my parabola to say I know one of the roots is 0, 0. Question 1, what is the maximum height? Great. So here's an opportunity for me to review what we did yesterday. If I'm looking for max height, what's the key point that I'm looking for? It is called the vertex. So question A is the vertex. Question B says, what is the horizontal distance of the ball when the ball reaches its maximum height? So question A is asking for this. Question B is saying, how far did the ball travel before it reached the maximum height? So question B is also about the vertex. Okay, folks, how do I get the vertex? What's the tool that I'm using? I'm going to complete the square. Anytime it says vertex, max, min, complete the square. Great. And lastly, what distance does the ball travel horizontally until it first hits the ground? So I am looking at this point here for question C. What do I call that point? It's not the vertex. It is the x-intercept, the root, all that stuff. How do I find that? I don't complete the square, I'm going to factor, or I'm going to use the quadratic formula. Right? So I've just done the whole question conceptually. Now I actually have to do the work. So for question A, let's start. And as I said, if you've already done this, you're doing the practice test quietly. All right, step 1, draw square brackets around the D terms. Step 2, factor out the coefficient of D squared. And I made sure it's negative. I get D squared minus. And then I go 0.4 divided by negative 0.002. Right? That gives me a nice number of 200. Before I finish
Please excuse the interruption. This is a message from the main office. TDSB facilities employees are visiting our school today and walking around this morning looking at and photographing our building, which will include classrooms and student spaces. Thank you.
They're just fixing the school. And they just have to announce that people are going to be taking pictures. So I took the coefficient of D, divided it by 2, squared it. I get 10,000, so I go plus 10,000 minus, why don't I just write 10K? Because this is messy as heck. Plus 10K minus 10K. I've got my PST, perfect square trinomial. H equals negative 0.002. Factor the perfect square trinomial, right? So I get a D. Is it a minus or a plus? Well, look here, minus or plus? Minus, because the middle term is negative. And then I have to take the 10,000 and take the square root of that. So what's the square root of 10,000? Well, it's 100 times 100 minus 10,000. Okay, last step. I need to get rid of the square brackets. So I multiply everything inside the square bracket by negative 0.02. And then 0.002 times 10,000 is 20. Negative times negative is positive. Okay, done. From here, I can find the vertex. It's 120. Go back to my picture. Oh, it went up 20 meters and it took 100 meters to get to get to that 20 meters. Okay? So the answer for question A, max height, is 20 meters. Question B, distance is 100 meters. We good? I forget who asked this question, but please let me know if you need more explanation. And then question C, how do I do question C? Oh yeah, I already made my plan. Question C, I start with the original equation in standard form, and I'm going to factor or use the quadratic formula. Now, whenever I only have a binomial, I'm going to factor it. Because I already see what type of factoring am I going to do for this? Yeah, I'm going to GCF. So my GCF is going to be the coefficient of D squared, negative 0.002D, And then I'm going to divide 0.4. And I know it's 200. So it's going to be minus 200. And then I get, okay, to use the zero product property, D has to equal to 0, or D has to be 200. I go back to my picture. Oh yeah, I already said one of the roots would be 0, and the other one is 200. And that makes sense because the middle point here is 100. Okay, so the ball traveled 200 meters. Questions? We good? Camille, was that good? You didn't ask that. I totally forget. I know there's someone from here. All right. Next, let's look at 16. We're only looking at 16C. 16A said, what is the vertical distance from the top to the lowest point? Okay, we're looking for the minimum. What is the length of the main span? Okay. So question C, at a horizontal distance of 50 meters. Okay, I need to draw my bridge here. Right, here's a bit of a different question because we have a right way up parabola. Right, it's a suspension bridge. Just imagine it's like, ooh, there's a bridge. And it's got a wire, the purple wire between it, suspending it. Okay. Or a cable, they call it, at a horizontal distance of 50 meters. So somewhere here, it's 50 meters from, at a horizontal distance of 50 meters from one end of the cable. How far is the cable below the top of the support tower to the nearest meter? Yeah. So what's interesting in this question is that the axis is actually, oh, okay, I got to move the whole thing. The axis, I drew the axis incorrectly because, how do I do it? Okay. Just going to delete the whole thing. So it's like this. I've got the two vertical parts of the rope or of the bridge. Then there's a cable that falls in the shape of a parabola. Now, in the question, they're actually measuring from the top of the bridge. So this is your distance axis, and this is the height axis. Okay, so we're going to have some negative values here. And they're saying 50 meters horizontally. How far down does the cable go? And so really it's saying there is a point here that is 50. Why? What is the Y value at that point? So if I know the equation, okay, and I have 50 comma Y, instead of Y, I'm actually writing the height because I don't know the height. But I know that D, for question C, D equals to 50 meters. So when in doubt, what do you do, folks? Substitute. Okay, words of the wise. When in doubt, substitute something in. If you're like, I have no idea what to do, I'm just going to put some number into the equation. Well, I can put this number into there and into there. And once you sub that in, we're going to get the height at 50 meters. Right? I'm just calculating at this point and getting a height. Does that help? Great. All right, folks. So on the let's go. I just want to quickly talk you through the practice test.